Hi guys, welcome back to my YouTube channel. Today we want to take a look at calculus and mathematics. So now when we talk about calculus is subdivided into two in mathematics. We have we have differentiation, and we have another one to be integration. So now we are going to take a look at this first. What is the meaning of differentiation in calculus? So what are we saying in calculus, in differentiation, is that if we have a function, we have y to be equals x raised to power n. So from here, we believe that differentiation of this, the first derivative will be dy by dx will be n raised to power n minus 1. So we believe that if y is given to be equals x raised to power n, y is a function of x raised to power n. So therefore the y dx equals this n will come here, x raised to power minus 1. So we're going to deduct this, and that is the key meaning of differentiation. So we are deducting in differentiation. Y integration, we are making an increment. So therefore, sometimes you can denote this, the y, the x. Note that the y or the x equals y prime. So that is another symbol for differentiation. So in differentiation, we are deducting, and that is why this simply means decrement. And that is why we can say this one we are making an increment. So now, for instance, when you have area to be equals pi r square, maybe you have the area of the circuit to be given pi r squared. Now if you want to find the a over the r, will be these two will come here, then we have pi r 2 raised to power minus 1, and we believe that this one will now be 2 pi r. And this is what, when you are differentiate with respect to a, and 2 pi r is the circumference of the cycle. So also when you have y to be equals x raised to power 3, so dy over dx, that is, you are differentiate with respect to x. So you are differentiate y with respect to x, so therefore we have this 3 will come here, then we have x raised to power 3 minus 1, and this will be equivalent to 3x squared. So when you are given something of this nature, what you are trying to say is that you are differentiating function y with respect to x. And let's take a look at more examples under this. When you have you have y to be equals 3x raised to power 4. So for this, we want to differentiate y with respect to x. So we are going to have it to be dy over dx to be equals, this 3 will come here, we have it to be, this 4 will come here, and we have 3 multiplied by 4 multiplied by x. This x will now be 4 minus 1. And so this one will now be 3 multiplied by 4 will be 12. Now this one will now be x. 4 minus 1 will now be 3. So we have this one to be equals 12x raised to power 3. And that's idea behind the differentiation. So let's take a look at example 4. When you are given y to be equals 3x cubed plus 2x squared. So to differentiate this with respect to x, so we can have it to be dy over dx to be equals, this 3 will come here, then we have it to be 3 multiplied by 3 dot x raised to power 3 minus 1 plus 2 multiplied by 2 dot x raised to power 2 minus 1. So from here, what we are going to have for this, 3 times 3 will be 9. Then this one will now be x raised to power 2 plus this multiplied by this will be 4. Then this one will now be x. So that means we have our dy over dx to be equals 9x squared plus 4x. So now the next thing is, so we have it to be example 5, where you are given y to be equals 4x raised to power 3 plus 2x plus 1. So this, we have it to be dy over dx equals, we want to differentiate the function y with respect to x. So this one will now be 3 multiplied by 4 will be 12. Then this one will now be 3 minus 1. Then we have this one will now be 2x. This power of this one is 1. So multiply by 1 multiply by x raised to power 1 minus 1 plus, note that differential of any constant, the differentiation of any constant always equals 0. So we have this to be equals 12x squared plus 2 dot, we have this to be x. 1 minus 1 will be equal 0. We believe that this one is equivalent to 0. So from here we have 12x squared plus 2. And this is, so therefore the y, the x equals this. And we can say equals y prime. And note that the y, the x of any constant always equals zero. So that means when your y equals 3, so the y over the x equals 0. Take note of that. So the next thing is, we want to talk about differentiation from the first principle. So what we are saying here is that when you are given this type of a diagram, by considering this diagram, we have a point x1 and a point x2. So the difference between this and this is change in x. While we have a point y1 to a point y2, why the difference between this and this is what? Change in y. So now, note that from the above, y plus change in y will always be equals x plus change in x. So, and note that our slope will now be change in y over change in x. So therefore, from here, we have steps. We have steps. So now steps. The first thing that we need, why we want to apply the differentiation from the first principle is that identify y, obtain the increment in y and x, that is y plus change in y will always equals x plus change in x. Again, make change in y, that is this, as the subject of formula. This again, divide both sides by change in x, that is change in x, in order to get change in y over change in x. We are saying our slope here. So after that, by taking the limit value of change in x to tends to 0, in order to change y over change in x to be equals dy dx. And this is our first derivative. These are our first derivative. So therefore, let's see example under this. So for example 1, when you have your x to be equals y squared, assuming that you want to apply the first derivative, the first derivative says that we need to identify y. We've identified y. The second one is obtain the increment in y and x. That is, we need to make increment in this. We have y plus change in y to be equals x plus change in x, but we have this to be what? To be square here. So from here we have y plus change in y to be equals, we can have this to be x plus change in x, and again s plus change in x. So with this one, we have our y plus change in y to be equals this multiplied by this, we have it to be s squared. This multiplied by this, we have it to be x change in x, and this multiplied by this, we have it to be x change in x, and this multiplied by this, we have it to be change in x all square. So from here, we have our y plus change y to be equals x squared. This plus this will be 2x change in x plus change in x squared. So from here, the third step says make change in y as, that is this, as the subject of formula. So we want to make this as subject of formula, then this one we could go to this side. We have to be change y to be equals x squared plus 2x change in x plus change in x squared minus y, this y. So from here now, from here, this change in y will be equals x squared plus 2x change in x plus change in x squared. Our y equivalent to x squared. So we have this one to be minus x squared. So we believe that this, we cancel this. So from here, this, we cancel this. So what we are going to have will be, we have our y, change in y to be equals 2x change in x plus change in x squared. So from here, we have our change in y to be equals 2x change in x plus change in x squared. So from here, the third rules or the fourth rule says, divide both sides by change in x in order to get change in y over change in x. So now let's apply this one here. We have by dividing both sides by change in x, we have this one to also be change in x, then change in x. So from here, we have change in y over change in x. So for this, we cancel this. So we are going to have it to be 2x plus, for this one and this will be remain 1. We have it to be change in x. And the next one says that we should let the change in x, by taking the limiting value of change in x tends to 0, in order to change this change in x to be equals to y dx, which equivalent to first derivative here. So we need to take the limiting value of change in x to be equal 0 for this change in y or change in x, and for this one will be, when we take limiting value of change in x to be 10 to 0 for 2x plus change in x. So from here, we believe that this one will change to dy over dx, and this will be equals 2x plus 0. And so therefore, dy over dx will now be equals 2x. So that's how to use the first principle to find the any differentiation given to us. So let's take a look at another examples under this. Assuming we have to be example B, when we have our y to be equals x raised to power 3. So from here, the first thing is we need to make increment in this and this. So we have it to be y plus change in y. Then this one will now be equals x plus change in x, and this goes to power 3. So from here we have y plus change in y. Then we have this one to be equals, we have x plus change in x, and x plus change in x, and x plus change in x. So with this, we have y plus change in y to be equals, where we multiply this, we have it to be x squared plus 2x change in x, and this we have it to be change in x squared. So, and then what we're going to have for this will be x plus change in x. So now we have y plus change in y, this will be equals, when we use this to open the bracket, we have it to be s cube, and multiply by this one, we have it to be, when we use this one to open here, we have it to be s cube. This multiplied by this, we have it to be 2x squared. Then we have it to be change in x. Then this x multiplied by this again, we have it to be x change in x squared. So plus, when we use this to open this, we have it to be x squared change in x, plus when we use to multiply this, we have it to be 2x change in x squared. When we use to multiply this, we have it to be change in s cube. So from here, we need to make change y as the subject of formula. By taking it to this side, we have it to be change y will be equals, by writing everything here, we have it to be s cube plus 2x squared change in x plus x change in x squared plus x squared change in x plus 2x change in x squared plus change in x cube minus y. So from here, what we are going to have will be, we have change y to be equals, when s cube plus 2x squared change in x plus x change in x squared plus x squared change in x plus 2x change in x squared plus s change in x cube minus our y equals, from here our y equals x cube. So we have it to be s cube, and believe this will cancel this out. So what we're going to have will be change y equals, now 2x squared change in x, and we have it to be x squared change in x. So this one will be 3x squared change in x, this and this. Then we're going to have it to be x change in x squared plus 2x change in x squared plus change in x cube, this. So from here, let the variable side by changing x. So from here, this we cancel this. So we have change in y over change in x to be equals 3x squared. And this we cancel this, it will remain 1. We have x change in x. Then this will remain 1, 2. We have it to be 2x change in x. Then this one will be remain 2. We have it to be change in x squared. So from here we have 3x squared plus 3x change in x, this plus this, plus change in x squared. So by taking the limiting value of this, we have limiting value of change in x tend to 0 for dy over dx will be, then the limiting value of change in x at x tend to 0 for this 3x squared plus 3x changing x plus changing x squared. So from here, we believe that this will change to dy over dx. And this one will now be 3x squared plus 3x into bracket of 0. This one will change to 0 plus 0 squared. And this one will now be 3x squared plus 0 plus 0, which equivalent to 3x. 3x squared. So therefore, the x equals 3x squared. So if you are new here, watch this video. Don't forget to share, like, comments, and subscribe to my YouTube channel for more mathematics tutorial videos. And we are going to meet in the part 2. Part 2 is coming. This is what part 1. Bye.